Assalamu alaikum everyone. Here's an exam question on circle theorems. Now before we get started, whenever we get a question like this, we're going to ask ourselves these three questions on the bottom right hand corner. So the first question is, what do I know about this topic? Second, how have I solved questions like this before? And the third question is, what do I need to be successful in this question? So I'm going to read the question first, and then we're going to answer those three questions. Okay, A, B, and C are points on the circle with the center O. CD is a tangent to the circle. Angle BCD is 40, so let me label this. Angle BCD is 40, so this angle here is 40 degrees. Yep. Let me lightly shade this here, so that one. Okay. And angle OAB, which is this one, is 3 times angle OAC, which is this one. So if I called angle OAC X, angle OAB will be 3x, because it's 3 times it. Okay, work out the sines of angle ACD. ACD is this one, so I'm going to mark that one with red. So I need to find the full angle here, ACD. Okay, write down any circle theorems that you use. So when it says write down any circle theorems you use, only the circle theorems as reasons, no other angle rules. Okay, so the question actually has a hint in it. It's talking about circle theorems. So there are 9 circle theorems at the GCSE level. To recognize which ones we have to use, we have to recognize the parts of a circle. So we have a radius and radius. There's 2 radii over here. We have a tangent, CD. And then it's also mentioned that CD is a tangent to the circle. Now, there are a few circle theorems that relate to the tangent of a circle. So radius and tangent meet at 90 degrees is one of them. Then 2 tangents from an external point to the circle are equal in length. And then there's one where it's to do with a line connecting the center of a circle to an external point. That doesn't really relate to tangents, but it has tangents involved in it a lot of the time. Yeah, we'll bisect the angles formed over there, and those angles are formed by the tangent. But also you have the alternate segment theorem, so an angle between a tangent and a chord. So we can see that this line here, CD, as mentioned in the question as well, is a tangent, and this line here, BC or CB, is a chord. So the angle between a tangent and a chord is equal to the angle in the alternate segment. And to find or recognize the angle in the alternate segment, it will do the following things. So the tangent and the chord connect to each other, right? So the angle in the alternate segment will start from one end of the chord that connects to the tangent. It will touch the circumference and then come back to the other end of the chord. So that's how you recognize the angle in the alternate segment. So in this case, this would be the angle in the alternate segment. So let me just mark an arc here for 3x. Okay. So the first thing I'm going to start off with is number 1 over here. Angle CAB is equal to 40 degrees. And the reason for this is angle between a tangent and a chord is equal to the angle in the alternate segment. So I know that this full angle now is 40 degrees. So the second step, I'd say x plus 3x. So if I add these two angles, I get 40 degrees. So 4x equals 40. Now divide by 4 and divide by 4. X equals 10 degrees. So this is 10. Then this will be 30. Okay, the next step is I'm going to highlight in red triangle OAB. Now triangle OAB is a triangle formed by two radii. OA and OB are radii. OA is a radius, OB is a radius. So this triangle will become an isosceles triangle. And in isosceles triangles, base angles are equal. So this angle here is 30 degrees. This angle here will also be 30 degrees. So step number 3, I'll write it over here. Okay, so angle BOA is 180 degrees minus the two 30-degree angles added up. 180 minus 60 degrees, which is 120 degrees. Now if you notice, I didn't write the reason down, and the reason for that is they only one circle theorems, and that's an angle rule, so I'm not going to write it down in this case. And then finally, so I know this angle here, this is 120 degrees. I shouldn't say finally, there's two more things I need to do. So number 4, this angle BOA is an angle at the center. To recognize an angle at the center, it is normally at a meeting point between two radii. So BO is a radius, AO is a radius, they meet at the center and they form this angle. That's the angle at the center. So this is the angle at the center. There is a circle theorem relating to angle in the center, and that is angle at the center is double the angle at the circumference. So I showed you how to recognize the angle at the center. You find two radii, and where they meet, that's the angle at the center. To find the angle at the circumference, you know the two radii we talked about, so OA and OB. So you see where OA touches the circumference at A. So to find an angle at the circumference, it has to start where the radius touches the circumference, in this case A, then go and touch the circumference at another point, which is in this case C, and then return back to the point where the other radius touches the circumference, so CB. Okay, so that's how you can recognize it. Okay, so these are the two radii, OA and OB. Can you see that? And then for another angle to be an angle at the circumference, it has to start from where the first radius touches the circumference, then go and touch the circumference at another point, and go back to the point where the second radius touches the circumference. Okay, so that would mean that this angle here is half the 120 degrees, which is 60 degrees. So the next step, number 4, angle ACB is equal to 60 degrees. And the reason for that is angle at the center is double the angle at the circumference. And I've almost run out of space, so I'll do number 4 over here. Finally, angle ACD, which is what the questions asked me to do. And to find that, I'm going to add this with this. So 60 degrees plus 40 degrees is equal to 100 degrees. Okay, and that's how we answer this question. I hope this has benefited, and thank you for watching.